Hello everyone, my name is Rafi Kurlancic, and today I'm going to talk to you about how to build a generalized streaming pipeline with Apache Spark and Kafka. So this talk and demonstration is going to be broken up into 5 steps. We're going to talk about my motivation for doing this project at all and why I think it's valuable. Then we'll go into what the question is that we're trying to answer and what data we're going to be using to answer that question. After we define those two things, we'll talk about the technologies that are used to solve that problem and the architecture involved. Once we finish going over those, then we'll go into the demo itself. I'll show you how to launch all these services and walk through the script that I wrote to do the data processing. And then we'll conclude by reviewing and talking a little bit about how IBM has made a significant commitment to Apache Spark. Alright, so why did I do this? What did I do? Why am I doing it? Well, streaming is becoming a much more prevalent feature in our lives. I mean, I think most of us love Netflix, and we use apps that stream data back to the companies that created them and provide information about ourselves, and that's really what companies and industries want. Is they want real-time data, and they want to be able to process it using sophisticated machine learning algorithms and advanced data analysis. So Spark Streaming is a great way to do that, and I wanted to talk a little bit about how that is. So we're going to do that in 4 different ways. We're going to showcase the simplicity and flexibility of the Spark API. We're going to join the streaming data that we get with data that's at rest. In this case, it's going to be in a PostgreSQL database. And we're also going to incorporate machine learning into our streaming application. And finally, we're going to store the results of our data that's been scored into an external database. And the idea here being that this is going to be like a general pipeline that you can use in a number of different industries. Okay, so let's talk about our data that we're using. The question that we're really asking is bot or not? And Wikipedia publishes a stream of recent edits that have been made. It provides information on the user, the number of bytes that they've manipulated, whether they added data or deleted data, and it also includes a is bot edit field. And this is a true or false field, and this is really what we want to know. We want to know if we can predict whether or not what class of edits have been made. Is it an edit made by a bot or is it an edit made by a human? And I think this is valuable because there are use cases in other industries where we really want to be able to classify streaming data. For example, let's think about in healthcare, you have patients on the ICU floor who are being monitored and have telemetry data that's constantly being created. Maybe we want to ingest that data and try to predict whether or not that patient's about to go into sepsis or whether they're about to crash, things like that. And then we could send an alert to the doctors. Or if you're a manufacturer, perhaps you want to classify whether the data coming off of your machines indicates that there are malfunctions or other problems happening with your machines. So we do want to classify real-time sensor data and streaming data. That is a problem that exists in multiple industries. Okay. So let's take a look at this data that we're going to get from Wikipedia. It comes in raw JSON form, and you see there's a number of fields here. There's the type of edit being made, the title of the article being edited, the user, the diff URL, the byte differential between before the edit and after the edit, summary of the edit, and so on. And here you see at the end is bot edit. So this is kind of interesting. This user Cars thought that it was very important that the world should know that Marilyn Manson um, has is not a rapper of note. I found that to be quite enjoyable. If we took this JSON and put it into a table or a data frame, this is what it would look like, and we'll see this more as we go along. But just to reiterate, the question is, this column here is bot edit. We want to know if we can predict if it's true or false based on some some combination or way of construing these other variables in the data. Okay, so what do we use to solve this problem? Well, the main thing that we're going to use is, once we have our data, we're going to use Apache Spark to process it and model it and then write it out to an external database. So what is Spark? Well, we could spend a lot of time talking about what Spark is. I'm assuming that the audience knows at least a little bit about it, but at the most basic level, Spark is really the heir to MapReduce. MapReduce is a programming paradigm for big data, where you have to write a mapping function and you have to write a reducing function, and there's a lot of input and output, writing to disk, reading to disk, when you try to do traditional data manipulation and modeling. This is just very slow. There's this bottleneck when you have to read and write from disk. And Spark was invented to keep your data in memory. And that gave rise to the concept of the resilient distributed data set. And it's spread across your cluster in the same way that the Hadoop file system spreads your files across a cluster. But instead of being on disk, everything is kept in memory. So now we can iterate over our data and interact with it in a much more efficient fashion. So that's really the value of Spark. It's built to handle things at scale. And the second thing we're going to use is Apache Kafka, which is a streaming messaging service that, as you see here, it can publish and subscribe to streams of records, store them, and even do some processing, as you'll see. So what are we going to do with these two technologies, these two open source projects? Well, we're going to basically pipe them. First, we have our data source from Wikipedia. Wikipedia is sending out a stream in real time of data, and we're going to draw that into Apache Kafka. Kafka is going to parse that data a bit, form it and publish it into topics that can be subscribed to. Spark Streaming is going to ingest the data from Kafka, where we'll start to do our more sophisticated transformations and filtering of the data. We'll also do the machine learning that we've talked about, and then we'll write it out to an external database. In this case, we're going to use PostgreSQL, which is an open source database. And yeah, that'll be that. Now, as far as different ways to do this is really just one particular instance of a more general pipeline that can be used. We could ingest the data from Kafka or Flume or HDFS or other sources, and then we bring it into Spark Streaming. We do all the work that we want to do to it, and then we write it out. We could write it out back to HDFS, we could write it out, or we could send it directly to a dashboard. The other thing I should mention here is that Spark Streaming is not truly real-time, to the microsecond streaming. It's microbatch streaming, which for many use cases is essentially the same thing as real-time. You can have data coming in half-second intervals, where it's being scored and sent to your application. So it's still very fast, and it's still very, very close to real-time when compared to other projects like Flink or Storm. Okay. And we've already talked about the different applications. So So yeah, at this point, we can get started on the demo. I'm going to come over here, I'm going to open up my terminal. And we're going to start a bunch of different services right now. So Apache Kafka is dependent upon Zookeeper. So the first thing you need to do is load up Zookeeper server, get that started. And we see that it's on port 2181. Everything looks good here. Now let's get Kafka server going. Okay, and Kafka is going to go back and look and see if there's any pieces of the stream, find out where it is in the stream, and load any offsets from that point. Looks like we're good over here. That's actually one of the benefits of Kafka, is that if your stream goes down, you can always go back and sort of rewind it and go back from a place where you were earlier. Whereas in Spark Streaming, that's not currently an option. So the combination of the two can be useful. All right. Well, now we're gonna load Hello Kafka Streams. This is the connector from Kafka to Wikipedia. This is a WebSocket connection, and Hello Kafka Streams does a number of things. It takes the raw data from Wikipedia. It creates several topics. It creates a Wikipedia parsed topic. That's the one that we're going to focus on. It also creates a Wikipedia raw topic that is less processed, as you would imagine. And lastly, it does some data processing of itself, and it prints a running count of the number of edits for each user to the console. So we're going to see that in just a minute. Okay, so now we can see the number of edits coming in and the users associated with that. And one thing I just want to point out real fast here is the JJMC89 bot. Now obviously this is a bot, and the thing that's interesting is that you can see the number of edits that this bot has made. It's far greater than any other user here, and this really holds true for other bots as well. It makes sense that a bot would have way more edits than a human, because a bot can essentially make unlimited edits, whereas a human only has a certain amount of time to do so. That's going to be one of the features that we include on our in our model to try and determine if it's a bot or not. Okay, so now that was the aggregated data from Kafka itself. Now let's take a look at one of the topics that is being published by Kafka. This is the Wikipedia parse topic, and this is the one that we're going to subscribe to and ingest into Spark Streaming and do all of our work on. So we're going to load a Kafka consumer, console consumer, and we're going to use Zookeeper on the local host, local instance of Zookeeper, and the topic that we want is Wikipedia parsed. And here we see this is the JSON coming in that we had previously looked at with the Marilyn Manson example. That was a real example, by the way. I did not make that up. Okay. This is the raw JSON that we're going to pull into Spark Streaming and transform into something much more useful. Okay. So when we submit our script to Spark, there's a couple things that happen here. First, I want to just go over what we're submitting to Spark exactly. We have we're going to tell it the number of cores that we want to use, and then we have to tell it the dependencies that it needs in order to execute this properly. So the first dependency, the first jar, is the Spark Streaming Kafka assembly. This is basically the connecting between Spark Streaming and Kafka, obviously. And then we also have to tell it Postgres drivers. Make sure that we can connect to Postgres. After that, we direct Spark to the script that we want to use. This Python script, direct Kafka pipeline 2.0. And then we also tell it the host and port for Kafka, and then the topic that we want to subscribe to. Okay. So now when this launches, the first thing that the script does is get the historical user edit counts from Postgres and prints that out to the console. Then once the connection is made to Kafka and is bringing in the data, there's a 12-step process for each batch of data coming in, each micro batch. And we'll go through that, but first what I want to do is I want to go through the script and just highlight some things that we're going to do. This is a very typical data science pipeline type of work. So let's just go over this. Okay. So here's our script, Direct Kafka Pipeline 2.0, and it's really broken up into a couple different sections. The first section is importing the libraries and classes that we need to do our work. The second is defining the Spark context and checking to make sure that the correct number of arguments were passed at the command line. One thing I do want to point out to everyone is this setting the log level. So you have your Spark context, SC in this case, and then it's a good idea, especially when you want to just be debugging and things like that, to set the log level to either error or warn, because Spark will print out a lot of info messages that will make it very hard to see what your output is. Okay. We're also going to have to define the streaming context, and this 2 here is the number of seconds that we want for each batch. We could change this to 1, we could change this to 0.5. Half a second is sort of like the recommended guideline for Spark streaming, but you can change it to whatever whatever fits your use case. And we're also going to have to create a SQL context. This is what we're going to use to run SQL queries against the data. This next section here is we're going to declare our variables, load any pre-existing data that we want to use, and the model objects that we've created in offline. Okay, so this is the first table that you saw there when we started up our script, the reference table of historical user counts. This is from CSV, so this is another example of how you can bring in data from external sources into your streaming pipeline. You can load data from CSV. You can also load data from Postgres. You could create this from Postgres at this point, at the beginning of your script, before you get to go into the processing of each RDD in a stream. But this is a good way to bring in external data into your pipeline. And then we load our models. We use PCA and Random Forest in this example. Okay. So an important step here is, identify the arguments from the command line and use that to create our Kafka stream. Okay. And then the next piece is, now we have our Kafka stream, we want to get the JSON from that stream. And that is going to be stored in the variable lines. Okay, just remember that for now. Now this method here, this process method, you can think of it as everything we're going to do to an RDD that is coming in through the stream. Every batch of data that we get from the stream is going to be manipulated with the commands and calls that we make in this process method. And the way this, we're going to go through this, but I just want you to see the way this works is that you take the lines, which is the JSON that you're getting from Kafka, and you call on this JSON, you call for each RDD the process method, and that is how your streaming data, your streaming application works in Spark Streaming. All right, so now let's go through, what we're actually going to do to this incoming data. So the first thing we're going to do is we're going to convert the JSON to a data frame and check the schema. And you'll see this in the console. We're going to print the schema. Okay, that's inferred from the JSON. Next thing we're going to do, in order to use Spark SQL, we're going to create a temporary table, and we just call the create or replace temp view method on edits RDD. And then to convert that to a data frame, we just use spark.sql select star from edits. Now we have a data frame of our original RDD. Okay. One of the things we mentioned doing was writing the streaming data out to external database. In the previous context, we had talked about doing it in terms of the modeling, like the final results of our analysis, writing that out to Postgres. But it can also be useful to write data out for archival purposes. So here we're going to write it out very, very simply. We've already defined ahead of time what the URL is for our connection, the table that we want to write to in that database, what mode. In this case, it's appending additional rows to our table, and then the properties of that connection. So it's very simple here. Edits, take our edits DF, we're going to write it through a JDBC connection, and then provide your parameters there, and that's it. It'll write it to Postgres for you. Okay, now we're going to keep moving forward with our RDD, with our data frame. I'm sorry. We're going to start doing the transformations and filtering that we need to do to do the modeling and such. To me, this is really the data science work, getting the data into a form where you can model it. So the first thing we're going to do is we're going to take that edits data frame, and we're going to add a column called addition or deletion based on whether or not the byte differential is positive or negative. Okay. The next thing, we're also going to convert the type column to a Boolean. So if it equals edit, then it's going to be a 1. If it's not, then it's going to be a 0. Then we'll update our temporary table that we created to run SQL off of with this new transformed edits data frame. Okay, now we have a couple more operations that we want to do on this data frame before it's ready for modeling. And I think this is a very powerful example right here. We're going to do 3 significant things in one SQL statement. We're going to get rid of some unwanted columns. So we're going to omit that from our statement. We're going to cast the Boolean column types as 0, 1 integers or binary variables. And the reason why we're going to do that is that that is necessary to use the modeling functions in Spark MLlib. And then we're also going to create 2 new columns based on the magnitude of the edit and the length of the summary. So here you see that with spark.sql equals select. We're going to take the user, the type bool, the length of summary as the summary bytes. We're going to take the absolute value of byte differential as the total byte change. And then we're going to change these other variables from true false into 0, 1s. And this is all done by querying that temporary table that we created. Okay. Now we're going to join our data at rest with our data in motion and create the modeling data frame. So we're going to add the user counts that we have, join them by user, do a left join them by user. If there's any missing values, meaning if we have a user who is not in our historical table, we'll just say that user has a number of edits of 1. All right. Now to do PCA in random forest, we're going to have to create a features column, which is a vector of all the values that we want to model in relation to the isBot edit column. I'm not going to go through this in too much detail, but that's essentially what these lines are doing here. And I also want to point out that we're using Lambda functions here. So far we've used the Spark API to do SQL and to do other basic transformations, and then here we're using mapping. We're using Lambda functions to map values, map inputs and outputs. Okay. Okay. Now, once we have our predictions from random forest, we actually need to create a index to join it back with the original input data frame. And the reason we have to do that is that in Spark you can't append a column arbitrarily to a table or a data frame. The reason is that because the data is distributed, there's no way to know where each data point should go. You need to have an index to join by and basically keep everything in order. So we're going to create these indices and then join the two columns together. Sorry, join the two tables together, the predictions and the input columns. All right, and the last point I want to make is that if you have nested columns in a R2D or Spark data frame, the way to access them is just to do a using dot syntax. So if you have a vector, one column that has columns nested in that, then if you want to access those nested columns, you just do, columns is the parent category, and then to access a nested one, you just do dot the name of the nested column. I hope that's clear. You might have to wait and see the script to see the execution and the printing in the console to make that clear. All right, well now we're ready to go back and see how this is running. Okay. All right, let's go back here. So remember we said the first thing we're going to do is we're going to print out the schema that's inferred from that raw JSON. And then the next thing is show that data frame that we get from the JSON using that same schema. All right, step 3, let's add those new columns, addition or deletion, type Boolean, and those are taken from the values in byte differential, whether it's positive or negative, and the values in type. Okay, and then remember when we had that SQL statement with all the different transformations and casting of different values. So that's this data frame is the result of that operation. We now have all of our types are correct; they're in the right format, and we've also dropped the diff URL column, and we added the total byte change. Okay. Another step that we wanted to do was join the data, the number of edits, with the incoming data. So we've done that here. And then we have to convert the features that we want to include in the model to a features vector. And you see that right here, the features vector right here. The next thing is we're going to use PCA on the features vector, and the reason we're doing that is really twofold. One is that we don't really understand so much about these fields, and PCA can help us sort of pick out what is significant in terms of variation and what is not. The second is PCA is a common tool in the data scientist tool bag, and this is a good way of just showing how we can build it into our pipeline. Is it necessary? No, it's not necessary, but for the purposes of demonstration, it's definitely handy to just have in here. Okay, so after we've done our PCA and we pass it to random forest, we get our predictions. In this case, we were correct. There are no bots making any of these edits. And now that we have our predictions, we're going to have to join them onto our original data frame. So we'll create the index for the predictions, and then we'll create the index for our input columns, and then we can join them into our final output data frame. And this is what gets written to Postgres. And just to make this clear, when I was saying before about accessing the nested columns, so we have the user column right here, but it's a subset of the calls column. So in order to access this for our final table, when you do your select statement, you do select calls.user, and then you'll get this, right? And calls.typeBool, etc., etc. Okay, so as the final part of our actual demonstration here, let's go watch this data coming into Postgres. So let's do a select count star from wiki edits parsed. And we got about 261,000 rows. What about the number of rows in scored data? 16,528. Okay, it's been a couple seconds, so let's go check and see how many there are in wiki edits parsed. Yep, we got another 23. And let's see how many there are in scored data. Got another 12. So as you can see, the data is coming in from Kafka, being published by Wikipedia, coming into Kafka. A lot of transformation in a very simple API happening in Spark streaming, and then it's being pushed to Postgres. All right, so now I think we can finish up our talk here. And just to review, like I just said, this is our pipeline, and I hope that it's clear at this point. And you can see how this could be generalized to different sources and different use cases. And I also hope that the power of Spark streaming and the API is clear. That's why I wanted to go through the script like that. All right, and just to conclude, we want to talk a little bit about IBM's relationship to Apache Spark and the Spark project in general. So IBM has really done a lot to get this project as good as it can be. Now, the second biggest committer to the project behind Databricks. Databricks was the ones who invented Spark to begin with, and IBM launched the Spark Technology Center in I think it was 2015, perhaps 2016, and it is basically a dedicated group of engineers, making Spark better. And I know one of our own IBMers, Holden Karau, just became a committer to the Spark project. There's also the educational and efforts made by IBM with Big Data University and other events that we put on throughout the country in person. And then also, IBM really kind of puts our money where our mouth is, exactly. Spark is infused across the entire IBM portfolio. So this isn't just something where we think it's good, we actually think it works for us as well. And this is becoming, you can see which APIs are really being used, and it's not a coincidence, I think, that Spark SQL and Spark Streaming and MLlib are becoming more and more used as opposed to the original RDD-based APIs. This is a very friendly, familiar language if you're used to doing data science in R or Python, and you're used to working with data frames and those types of operations. This is going to feel like, pretty close to what you're used to. The main difference being that you do have to think about things a little bit differently because you're working on a large distributed data set. That's really the kicker. But I think this is rapidly becoming one of the easiest ways to work with big data in a rapid fashion as well. Okay, and if you want any more information, there actually is a GitHub. I will post the GitHub link for all these assets in the description of this video. And if you wanted to know more about Apache Kafka and Apache Spark, you can just go to kafka.apache.org or spark.apache.org. And I'll also include the link for the Hello Kafka Streams GitHub and blog posts from Confluent, so you can go into more detail if you want to understand that. So thank you very much for your time and your attention. I hope this was of interest to you. Please contact me if you have any questions. My email is rafi.kurlancic@ibm.com. And yeah, I hope you enjoyed. Take care.